Hello everyone, hope you're all doing well today and thank you for joining us for Ask the Expert Perform at Your Best with Postgres. We're just going to wait a couple of minutes before getting started to allow everyone who has signed up time to join, so please stay tuned and we will be kicking off shortly. Hi everyone, we're ready to begin. So thank you again for joining our Ask the Expert today. My name's Alice and I work in the marketing team here at EDB. And I'm just going to run through a little bit of housekeeping before handing over to Kevin Lee, who is our Sales Engineer Director in EMEA and is going to be your host today. So the first point to make you aware of is that we are recording and we'll be sharing the recording alongside the slides after the webinar. And secondly, the lines are muted. So if you have a question, please send it via the Q&A question panel and our experts will be answering these throughout the session. We do have a prize on offer like usual for the best questions. So please ask away in the Q&A panel and any questions we don't have time to answer within the hour, we'll aim to follow up with you afterwards. And that's all from me. So now I will hand you over to Kevin.
Thank you, Alice. Hi, everyone. Hope everyone doing well. It's a hot day today, so keep yourself cool and hydrated, drink a lot of water, and sit comfortably and enjoy the rest of the presentation. So let me just do a quick intro. My name is Kevin Lee. I'm responsible for the sales engineer in EDB, and I have the pleasure from Piotr, who's an expert in the database and also the performance and tuning that he's going to share with us the best practices, experiences, as well as some of the hints and tips. And alongside, we got two experts in the panelists, Rob and Ed, is going to answer questions you might have during this session. So any question that you might have, please use the Q&A panel and you can post those questions and we will either answer it directly through the Q&A, or we're going to answer it during the session when we have the Q&A session. So with that, I would like to share the agenda. So a lot of time people talk about performance and tuning. Performance like speed, right? How fast you really need. So what is the definition of performance? How do you measure that? What is the requirement you need? And then we will talk about what are the key challenges. A lot of time people thought about those queries, is it CPU power, networking, or storage? What are those effects will have an impact to your performance, your database and applications? And then we come up with some of the highlights of best practices as well. So what are the things that you might need to consider? What are the things that we can advise you to look in those specific topics? And how can EDB help you and assist you when it comes to performance and tuning? And we end up with a demo, of course, with a technical session. We need to show some of these capabilities. So we're going to use a Postgres Enterprise Manager to show you some of these topics. So again, Alice said we're going to give out the prize a 25 euros gift card. So if you have some interesting questions, please post them to the Q&A. So let's talk about good performance and what does it mean. So Piotr, can you walk us through your definitions, your experiences on these topics?
So good performance may mean completely different things. It depends on the application, it depends on the workload, it depends on the business requirements. So if you require short response times, we talk about the speed. If we talk about more operation per unit of time, you will need to handle more workload, more operations. This is about the throughput. But we need to remember about the scale of our solution. How many users should we serve? How many operations are we expected to serve? And how much data should we handle? Should we keep? Should we look into? So the question is, the key challenge is it possible to satisfy all these features in the same time? So if we want to speed up, can we scale out? Can we go for the bigger and bigger database? If we want to improve the throughput, process more and more operation, can we keep the same speed of the performance? These are the questions we can face very frequently, and there are some things that need to be considered in order to answer them properly. So if we can go to this next slide, let's understand how fast can we be, how fast can we be as of 2022. The change is observed in the different architectural and technical solutions. For instance, the random memory access time is now in the range of few nanoseconds per single read. If we measure the single query, the very, very simple query execution time, it can be few microseconds. Just imagine, we can handle almost 1 million of very small queries in a second. This is the border we can easily achieve if we run it properly. Just compare with other things. TCP/IP latency, we should consider. It is hundreds of microseconds if we use TCP/IP stack, regardless we use gigabit Ethernet, 10 gigabits or 40 gigabits Ethernet. The thing which is now very, very fast comparing to the history, I would say 10 years or 15 years, is the disk technology. Today, we can easily utilize flash or SSD or NVMe disks, which speed up the operations dramatically comparing to magnetic disk we used to use 15 years ago. To focus on the database operations, if we think about committing the time to spend to commit, we can estimate it can be hundreds or hundreds of microseconds. This is the speed we can achieve. It can be in some range of result times depending on the infrastructure, but these are let's say the averages you can assume as a first guess. A very important thing is the one TCP/IP round trip latency, because nowadays you can have a remote data center, you can have disaster recovery and production data centers with a distance of kilometers, of hundreds of kilometers, or even can be geographically located. To make these numbers, let's say, more visible for us, just go to let's go to the next slide, and let's understand how to compare them. Just imagine, single query execution time is a factor 1. Latency for TCP/IP is multiplied by 100. Just imagine, we want to bake a cake, let's say apple cake. We need to bring some apples to make it to our table. If we want to, if the distance is 1 and we need eight apples, we need to make 8 steps. If we want to go through the network, we may need to make around 1,000 steps. So to go to another room for the apples from the box. So these are the things that we should be really aware of in designing our architecture, because the database response time is the one of the factors, but in overall architecture, it is very, it can vary on the other architectural components like disks we want to access, the network we need to transfer the data through. So I think this is the time to poll. Just imagine, there is a small query that executes in 5 to 6 microseconds on average. Can we expect that almost all query execution times, it is 99.999%, will fit in 10 milliseconds response time window? So how do you treat it?
Yeah, we give a couple of seconds to the audience to vote. I think it's a very good question, and the speed is always like, you know, how fast is it? What is the understanding, and what is the use case? It's always also price as well. So I think it's a good, interesting question. So Alice, can you show us the result, please? Oh, fantastic. So we got a balance, right? We got a,
Yeah.
yes, we are safe, and then we can't evaluate properly because some people don't even know what the use cases are. So I think it's a good balance. At the same time, people need to understand.
To be honest, there is no, I would say, if there is no single valid answer. It depends on the use case.
Exactly.
Because if you enter the high frequency trading case or gaming, where the response time is critical, we are not in the very safe side. If we talk about real-time systems, of course we are not. But when we have the general purpose systems, we can assume that it is quite safe. But be careful with the averages, because the same averages of, let's say, 0.565 microseconds can be produced by the variety of response time distributions. There are two cases, two tables. These are the tests which run hundreds of thousands times, and we collected the distribution of response times in the buckets, representing every single range from 0 to 8 microsecond, 9 to 23, and so on and so on. In the table above, we didn't catch any kind of response time that could raise the concern. But the same case is for the table below. We have the same average query execution time, but we see two buckets from 8 milliseconds to 32 milliseconds, which is very close or above our expectations of 10 milliseconds, or 22 milliseconds to 131, which is apparently a problem, the same average value, but different distribution. So let's be careful about that. So if we can go to the next slide, what are the key challenges? And what can go wrong with such an easy query? No, this is the query for accessing the table through primary key with a filter. Of course, SQL query plan could be non-optimal. This is the topic we could face. But in such case, we will most likely get consistently query execution times that are not satisfying our requirements. Execution costs can go above the expectation because of various factors. Just need to be careful. This is multi-user system. This is high. There is a kind of concurrency. There could be conflicting workloads, and we need to understand what are the impacts of transactions running concurrently on the same tables. If they are running massively, the response time of such kind of sharp queries could be affected. The results will be valid, but the execution cost can be a little bit more, can be increased. There could be some generic platform topics and generic platform performance issues, like a scheduler. If we have very busy system with CPUs, we cannot get the CPU for processing early enough. We need to wait. There could be some memory management problems, because if the system is running out of memory or very close to out of memory, there could be some paging and swapping introduced. It could be also conflicted with operating system buffer cache, which can aggressively cache the access to some file systems. So we need to balance and control many factors. These are the examples, but it is of course not the complete list. Yeah. Just can we go for another poll? This interesting question.
Yep. So shall I read it out, Piotr? So what CPU usage should be the maximum when we focus on the stable short response times for small queries? So is it more than 95% or 80% or 60 to 70% or less than 50%?
Yeah.
So just give a few seconds.
It is typical OLTP workload. We are focused on the response time. We don't want the system to be all right.
Okay. So we have 60 to 70%, most of them, and
this is the typical. This is the typical, assumption for the scaling the systems.
Yeah.
If we want to have, let's say, the amount of CPUs calculated, what is the marginal capacity, which we cannot be exceed. We should assume 60 up to 70% of processing of CPU. 50% is not bad, because it means that you are really committed to short response time, and you can decrease. Going above OLTP is a little bit risky. For data warehousing purposes, it is another story.
Yeah. So we're going to talk about the latency, right? Because this is also one of the effects when you have multiple servers running. A latency could be a bottleneck. So you're going to walk us through about the networking?
Yeah, this is a very common topic in the distributed environments. It is not new one. Maybe it becomes more popular when we have cloud environments with the different regions, and we want to connect application servers from on-prem to cloud, or from cloud region to another cloud region. What should we consider to have the reasonable application response time when the topology is a little bit distributed across the regions? So just let's understand what are the typical latencies between the components. If we look on the left side, the application servers. One is connected to the database through LAN network with 200 microseconds latency, which is quite good. WAN network, which is in the same country, probably the data centers are in the same country, at least in the same region, with 20 milliseconds, or a little bit more, a little bit less, and very wide, very long line with WAN with 100 milliseconds. Will application run smoothly? I don't know. It depends on the characteristics of the application.
I suppose also depends on the expectation of the users, right? Let's say you were talking about gaming, you really need very high speed. But if you're looking for a report, people can wait until you get the report, and they don't mind to wait for maybe 5 seconds or 10 seconds. Maybe that works as well, right?
Yes, I think there are a couple of factors. We need to, first of all, we need to understand how often the applications should call the database in order to provide the response to the user, or to provide the response to the calling function from the integration or whatever. If just assume we need to call the database 40 times with LAN, with local network with very short latency, we don't even see this network latency. But when we go with 100 milliseconds of latency, for 40 calls, you will have 4 seconds. It will become visible. And more important is just to consider just to have overview on the application. Can we optimize the networks and traffic between the application and the database? For various purposes.
Now you mentioned a very good, interesting, right? You talk about core CPUs. We're gonna go through this.
This is another story, because this is throughput. Just we came from speed, go to throughput with the acceptable response time. We should start with the business requirements. How much workload should we handle in a unit of time? It should represent the business activity. So if we need to process, let's say, 1 million invoices in a day, it is the throughput requirement. If we need to ship 2 million packages per day, it is the throughput requirement. And it is defined by the application. It is not about the database technology that much. It is about the application, how it is designed. So if we go to the next topic, it is the topic that should be answered by the analysts or architects. What is the approximate database size, concurrency level, and how much is it relevant to the business requirements? This is the design of the application. And when we go to another topic, then from this scale and the business requirement, we can estimate the specific configuration that should handle that traffic on the assumption that the application and design is done properly. It means hardware network resources, for instance, CPUs, RAM, the disk, and let's say the disk specifics, software components, and what will we at the end measure when we run the system? Of course, business activity. How many business operations can we handle? What are the response times? So are they acceptable or not? And we need to measure technical things like system and database load, because we need to answer the question, can we handle more load? Should we expand our architecture, or are we on the safe side?
That's great. So we're going to talk about this, about handling more workload. Should I add more CPU, right? You're going to walk us through about CPU power.
Yeah, you know, it is so easy. Just add the CPU. Of course, in many cases you should. But before saying that, you need to understand, where is the bottleneck? Is there a bottleneck? Is it a relevant answer for your concern? Because it depends on so many factors, and you need to consider them. If the system architecture is improper, for instance, you spend processing time in the network because of the collocation of the server, adding CPU will introduce no improvement. If the problem is with the database design, you may somehow help with the CPU power, but the root cause lays somewhere else, because the queries, the database design or the queries are not functioning properly. So you need to focus on the root cause in order to scale your system and provide you the required throughput and response times.
So with that, I think a lot of people talk about vertical scalability, horizontal scalability, and it really depends on the use cases, right? It's not like you can chuck in a lot of irons, CPU power, you change the machine, it will magically, it's going to speed up 10 times or 20 times. It doesn't work like that, because sometimes it does, if you're lucky, but sometimes it's really depending on your schemas, your structure, your data, and your applications, right? It's a lot of criteria on that.
Yeah.
So that's great. So you're going to share some of the best practices, Piotr.
Yeah. So I think the first hot topic, one of the most relevant for the database performance, is the disk. What is the disk we should use for the database? And you know, I need to admit there is a tremendous improvement during last 10 or 15 years, when we went from the magnetic disk times to the solid state disk, flash memory, NVMs, and so on and so on. Now we can enjoy much better performance in terms of number of random IOs. It means, so it is random access to the disk, which is very typical, very typical workload met in the database, which is scanning the data through the indexes. So we need to scan the index with random IO. If we need to collect the blocks to satisfy through the index scan, we need in most cases we'll go through random IO. If we go with the background writer to the database file during the checkpoint, it is random IO. So these are the critical patterns. So the solid state disks, flash memory, or overall, let's say, silicon-based disks are tremendous improvement. Of course, first years were quite difficult. They could not provide the sustainable write speed, but nowadays it is much more stable and very high performant. So the question is, what kind of disks? So it depends on the characteristics of data. In my opinion, every database, if you want to run in a large scale, or you don't know what will be the scale, just consider to run on the SSD, appropriate speed, if you can afford. But if you cannot afford that, you need to understand what is the load pattern, what is the load pattern of the data, how often it is randomly accessed. If, for instance, you have a big archive data, which is used for sequential scans, very, very rarely with random IO, you can use a set of high capacity hard disks, no worries, but you need to be sure that there is the workload, this pattern of workload will direct it to this kind of storage. And you know, with OLTP systems, there is some kind of consideration. It is containing a lot of code data, which is frequently changed with random IOs, of course. But OLTP systems can be also optimized by providing the tiers of the data, which is accessed very rarely. For instance, historical data, you can tire it to the cold data storage. For data, which is processed sequentially, but you need to consider that you will access through indexes. If you create the indexes in your data warehouse, you need to be prepared to have random IO.
Yeah, so I think you can mix and match, right? People started with the production with the hard disk, with SSD or flash, but you can also use the backup of those, and you can use archive data with tapes. So it's much more cheaper. And some of the businesses requirement is like you need to backup for 20 years. You're not going to store in the SSD, right? You probably will store some of the data into the tape. Yeah. Yes. So I think it's not like a one story fit all. I think it depends on the use cases, and then you balance it out with the time requirement and the money that you're going to spend. So I think these are also the best practices to understand the characteristics of the use case and your application. So so you're going to talk about, before you go live, before you're changing. So you're going to walk us through, right? Well, what are the toolings? What are the things that you can help?
I would like to highlight one thing. When you want to prepare for high performance or well performance, you need to test. You need to test before going live. You need to test before introducing any kind of change, like upgrade or introducing the schema change and so on and so on. So there are two types of, let's say, testing tools which provide some workload you want to measure and optimize your system. So one is this predefined database log generated category, which are very nice, and they are useful for certain use cases, like HammerDB, like pgbench, like other, let's say, synthetic workload generators, because you can stress test the infrastructure. You can see what are, let's say, the limits. You need to, you need to test the limits. How many transactions, how many IOs you can handle. This is really very good test case. You can tune your checkpoints. It is very important thing for stable response times and for your throughput. This is really useful, but it will not test your application. You need to go through application testing tools, and you can use application testing tools to test your application from the access layer to the disk, just to generate the load and to see how it will behave, not only in the database tier, but also on the different tiers. And you can just match where is the response time and the application and the database. And this is the key we would recommend. However, we are fully aware that it is not an easy task to prepare and maintain appropriate workload definition set. It means test data, test database, test case data. This could be another project.
Yeah, absolutely. I think some of them in the benchmarking, it works with the network and the CPU power and the database layer, but your application doesn't work very well when it's communicating. I think this is a very important thing that people need to test, not just the database level, but also working together with developer, developing the application that also optimizing the application access, the data. Yeah,
many different things.
So what are the things that you can talk about in terms of recommendations and orientation and observation?
Yeah, from the database perspective, we can utilize platform level observation like CPU, memory, IO network, whatever you can read on the operating system kernel can be used for performance analysis. We can identify sessions which are killing the CPU. We can identify the paging activity, and so on. Postgres kernel, which is very nice set of metadata about the configuration schema, metadata, and server level performance. EDB also extends this metadata with its own libraries. You can use as an extension. So it is wait state analyzer. You can extend by SQL profiler just to analyze the workload you selected. And for instance, you can run index advisory, which is also an extension. So this will reflect some kind of loop, I would say, or observe, orient, decide, act. So when you have, once you pass some health checks with static analysis, like is there an application misconfiguration, like the foreign key index which is not indexed, or let's say obvious error in the configuration, then you can observe it, as it will get reasonable measures in the performance, and then you can tune the database in the next step. It can be database server, it can be SQL or database structure. This is the thing that we recommend, just to health check, just a kind of hygiene for the configuration and the database schema, observe systematically, and once you discovered some patterns of wrong performance, immediate action to remediate.
So you're going to talk about some proactive, activities. Like
I think
hygiene.
We are running almost out of time because
I think so too. So we will share the slide there and everything for people to read. And you got some really good, things that you can share, right? What can EDB help in terms of database performance?
Yes, this is basically again support. This is you need to you can check your configuration with tuning wizard, Postgres expert, just to find out whether the memory is properly sized, whether there are some misconfigured things. I mentioned about, for instance, this is a very common situation, the tables with foreign keys, which are not, and the columns constituting foreign keys are not indexed. This is just a call for problem. Then continuous database runtime diagnostics by many facilities. You need, in the production, or even during the benchmarking or testing, you need to measure things to understand what is the load pattern and what are the anomalies. Without that, you cannot say that something changed, something happened after some actions. So it is done both on the database infrastructure level, so the operating system and so on, but also on the also on the database kernel. So the most important thing that I would like to highlight, that there is a persistence in the repository. You can get the historical data and compare the periods, or just to see what is a long-term pattern.
Yeah.
Optimize.
So all this stuff, right? You're going to demo, I think, some of the stuff. I think they can read all this stuff, and we can share all the slide deck with them. I think people wanted to see, okay, we have professional services can help you also to design some of the optimization. I think people are eager to see what can the tool do, right? So I think you're going to share the dashboard. What are the dashboard view in the database server? You're going to analyze the log tree using some of the sessions activities panel. You're going to have an application server sessions looking at the logs and identify the logging sessions so that it doesn't log the CPU power. And then you will also identify some of the sessions. What are the queries that's consuming CPU power? So I'm going to stop sharing my screen, and I'll let you run the demo to the audience, Piotr.
I will kindly ask for a few minutes because my browser stopped working, so I will try.
Okay. Yeah, I think there was something hiccup as well from your side while you're talking. So maybe there's something happening with your network. I mean, that's also the challenge we have when we work from home, and then we don't know all these internet provider, what they're doing. And then maybe there's a dip, and then you have to start everything all over again. So maybe we'll give a minute or two.
Just a minute.
Okay.
Because my Safari web browser, which I tried to use for presentation.
So meanwhile, I think when people are, I can see some people also raise their hand. We will answer some of the questions at the back when we are done with the demo. So please post those questions. We have a very active posting in the Q&A session. So Ed and Rob must be really firing up answering those questions. And we'll pick a couple of those questions after the demo. We will go through them together. So Piotr, whenever you're ready, you can share. Then I already stopped sharing. Yeah. You okay, Piotr?
Yes, I'm fine. Just restarting this the demo from another browser.
Okay.
So this is unexpected.
It's always with the live demo, right? When you do that at the beginning, it works, and then when you run it, and then something happened.
Yeah, this is all the thing we have. Okay, it is the good thing that infrastructure works. So this is not the problem with the demo set. All right, so I will try to now to share the screen.
Yep.
All right, where is the screen sharing? This is the screen sharing. Okay. Okay.
Yeah, it's coming. Yep, we can see the film. Yeah, great.
So let's assume I'm the administrator, or let's say I'm responsible for troubleshooting the performance, and I got the call for the database, which starts to respond quite slowly. There are some couple of problems, performance problems, and I need to have a look what is going on and to remediate the things that I could remediate in the let's say reasonable time. So first of all, with PM, with Postgres Enterprise Manager, I can see overall database picture where I can observe the server sessions, and I see that there are quite nice amount of active sessions which are probably responding probably responsible for the database load. I will also look at the operating system. I can do that through top Unix tool, but I can have it in the same console to observe the CPU. I see the CPU is saturated at the moment, over 99% of CPU usage. So CPU is certainly the bottleneck. However, is it the only thing? Because maybe the database is doing the things that it's expected to do at the moment, and it is all about the scale. I need to understand what are the things, what are the root causes of another performance problems. So it can be some weights which are not reflected to CPU. And when I go to the performance diagnostic, which is based on the weight states, I see the quite big number of logs. So these are the logs. I have, let me check. It is constantly for over an hour. Oh my God, this is not good. I can scroll and I see that this is constant pattern. So it takes for over an hour. To be honest, I ramp it up before the presentation. So this workload is now going. So I see 5 sessions waiting for logs, and 1 session which is waiting for IO or for another wait event, which is expected. So we see the problems with logs. We see problem with CPUs. We see problems with the statement which is committing the data every row inserted. So I need to schedule and make appropriate priority of action. So let's start from the things that are most expect to be most easy to manage. So let's go to the logs. I want to see one thing, show one thing. So when we can trace and we can see the active sessions. So sessions waiting for the log are active sessions, and all of 5 sessions are connected through JDBC driver. So this is an application. I can understand. I can look for the logging session, and I also want to see what are the statements executed that I are waiting for. So this is the same update. They are incrementing the same value, the same row at the same moment. It is not a good approach, but let's see why they are waiting for something, because this workload was handled properly before. So we need to understand. We need to look at this session which holds the log, which is that one. I issued the update and the session psql command with the psql program, but I didn't commit or didn't roll back. So all the application traffic is now affected. So either I can call the person who wrote this statement, or I can kill the session. Oh, okay. I couldn't reach him by phone. There's a decision to terminate this session. So I will terminate the session, and I expect the things to be a little bit solved a little bit. All right. So there are still some logs on the performance. When we recheck after terminating the session, we should be able to see that the logs are not that high. Okay, this is this period. Of course, there are some logs because of the nature of the application, but the number of sessions waiting for this log is still decreasing, because this is not the constant log wait, but from that they will wait from time to time. Okay, so I solved the part of this problem, locking the sessions logged by the uncommitted transaction. So let's go to understand what can we do with the sessions which are, let's say, eating the CPU. It was on the second point in my priority list. So let's see what is going on. All right, so state. There are some suspected sessions which are active and there is no wait event associated. I expect that they can run quite short queries, but very frequently and consume CPU. Yeah, this is this point of query. I can somehow verify by session activity view, because when I sort by CPU usage, I see these sessions, and I can compare it after, are getting 75% of CPU each one. So these are 2 application sessions connected to application user and eating up the CPU.
So Piotr, are these queries from those 2 sessions stuck there and taking a lot of CPU power?
Yeah, so these are, let's say, the queries.
Yeah, I see.
But to be honest, we captured the session state in some moment. We cannot say it is persistent or not. In order to understand what is going on in the sessions, I will use the tool which is performance SQL profiler. I can capture the workload from the sessions and see what is going on. I will create the trace test I will select the user. I will select the database which is running on and try to see what's going on. Lots of queries. Okay. Very often. So I see they are executed in 22 milliseconds, 24 milliseconds, 24. So they are not very, I would say,
not very quick in
not
20
very
milliseconds.
quick.
Yeah.
Yes. Okay, I can see the plan. It is full scan on the account table and in the loop getting the rows from the another table which is owner table. So what can we do? We can run index advisory. And it is almost, the results is almost immediate. The recommendation is to create index on this sequence of columns, account type and valid from. These are, it is probably missing index. I wouldn't say this is the design problem, but this is about the workload which is issued. So let's try to verify whether this query will be improved when I create the index.
Are you going to create now the indexes that
Yes.
advised by an index advisor?
This is the index. This is advised.
Okay.
This is, let's name it account. It's created. And let's see what will be the outcome, at least in the case of query. I wouldn't say will it reduce the workload. I don't know. It depends on the application, because no, these are very short queries. The application could flood the database with as much queries as possible, and this could be the thing how it is written. But at least we did whatever we could to bring the database to the state that we can manage. I will. Where is my? I will disconnect.
Are you gonna show again the CPU?
Yes.
Now they are running? Okay.
I will show I will show
The queries, right?
The queries, how it is affected.
Yeah.
So let's go. I've created the index.
Yeah, you did.
Of course, I would say the application is not very nice because it is flooding the database with the queries. But let's see how the query response time changed using the same SQL profiler facility. So let's create another trace after introducing the index. So we go with application user, the database the same. Let's see, can we do that? All right.
Oh, so now it's now a factor of 10 instead of 20 milliseconds, now 2.
Yes.
Because of the index.
Because of the index, I wouldn't say that it is the thing that will reduce the pressure on the CPU. Because if the application is just throwing this SQLs to the database as fast as possible, the CPU will be consumed. But the response time from the database side is much faster. And now it will be the point to ask the application developers why we query the database with such amount of the with such amount of queries? Is it reasonable? Does it represent the legitimate business activity? And you see the different query plan. It is just nested loop, but using index, or just created index on account table, which is
great.
Which was
That's a great demo. So you just using the Postgres Enterprise Manager to look at the query, look at those usage, and then get the advisor, and then you can use that to tune your SQL by applying an index in order to speed up the query. That's great. So
yeah.
I think we're done with the demo, right? Should we go to the Q&A?
I think so. There are another things to present. Because I didn't clean up all the, let's say, problems.
Yeah.
But at the time is going.
Yeah, I think it's a huge topic, right? I think you just touch base a very high level of things that you're talking about performance and tuning. I think there's so many different areas that you can look at. And if we look at some of the best practices you cover, and the demos only touch a very high level, very small piece of the best practices. So let's move to the Q&A. Let me just share the screen. There are some questions, right? We already answered a lot of those. I mean, Ed and Rob did a great job answering a lot of those questions. So maybe I just pick a couple of them on the Q&A. So there's one from Alexander asking when it can be necessary to consider commit time separately from insert, update, and delete cumulative operational time. So when do you think that is better to consider commit? I suppose you don't want a very chatty, right? When you have insert, you commit, insert, commit, and you have thousands of those DML. I would say it's not very efficient. Then you're going to increase your IO when you do commit, and you generate a lot of log files. So I think it's not very efficient if you do that. Every insert and delete, and every DML you do the commit, right?
If your logical transaction is just one insert, maybe. But if you need to load some bulk file, it is not efficient, because it is, it is much better to commit after 100 or 1,000 or many thousands of inserts, rows. You may consider to insert by array of rows. It's another optimization. However, if the approach is to make an auto commit after each DML, it is a little bit risky for two purposes. For the performance, which means that we will wait, the session will wait for wall sync time, because the wall writer needs to sync the data to the disk and then allow other sessions to continue after the commit.
Yeah,
it will be the bottleneck after, if you want to have it done serially, or we expect to let's say to process more rows. And the second thing is how it relates to the business transaction. Because if we just insert, update, yet another insert and delete in one logical transaction, and we need this ACID properties to be served, we have no choice. This is the thing that we should do, and that's the matter of fact.
Yeah. So Piotr, we have another question for Wojtek. As the storage, can I connect to the SDS, software defined storage? Does EDB support that? Do you know?
I think it should be a little bit more elaborated, because if this is the storage that it is presented to the Linux kernel and we can mount the file system, there is no, let's say, we just serve the storage which is mounted on the ext4 or XFS file system, and this is the base answer. What is below? It's another story. because it can be the storage array, it can be something that it is served by on the virtualization level or below. It is just integration practice.
Okay, so I think we got a couple more minutes to answer questions. I think two or three more questions. Is there from Benedict Kasperic, is there a possibility to solve the log without killing the session? Maybe the session must be complete a series of important tasks for the applications, like a very long transaction.
Yes, of course. On the demo I demonstrated, there was an idle session for a long time. That's the reason to kill them, because it is it could be the P-SQL session when somebody logged in, make an update and lock the screen and go home. It can happen from time to time, maybe not very often, but when it's a transaction, yeah. I can totally agree that killing the long-running transaction is not a good idea.
No, I don't think so, because there are a lot of dependencies, right? Yeah. You don't want to kill a session and hey, where's my money gone?
Yes, and the rollback is expensive.
Yeah, exactly. We need to understand the process. Yeah, for the demo's sake, I think we can kill it, but in real life, we don't kill sessions. For that.
There are some cases when we need to kill, the sessions that are, let's say, that hanged for some reason and were not terminated by the database server, and somebody who left the open screen with a screensaver and with open database session without committing or rolling back transaction is one of the stories. It can be stateful application, which when somebody entered the form, made some changes, posted to the database, but not committed. And
a quick question here from Peter from America. Your demo, right? And also, is that a per PostgreSQL server we monitor, or can you have a multiple databases you can monitor?
Oh, we can have multiple. This is you can for instance, if you want to trace, you can filter the database, because you can trace all the databases, but it is not maybe not relevant, because we will collect a lot of information in the logs. You need to filter after, so it is much better to filter before you collect, just to limit the number of logs and limit the overall impact of other sessions. And yeah, the database level is the level of granularity, and the user level is another factor of granularity. Regarding when I talked about this SQL profiler and tracing, regarding this figures, and then this is per server. So this is regarding overall weight states. But when you look at the, for instance, top sessions, which active sessions, you can see what is the database you are looking at. Yeah.
Cool. Yep. And I think we got one more question, time for one more question, right? Let me pick the one. I was looking at this, and then oh yeah, with the so Ano asked, hey, is the Postgres EM, the PIM, a EDB proprietary software, or can it be downloaded from the Postgres website? So yeah, do you want to answer that?
Me?
Oh, should I answer? So the one that Piotr just demonstrated, it is built and developed by EDB, and actually it is coming, some of the stuff that came from an open source from pgadmin. You might see some of the user interfaces and some of the things that are very similar, but we enhanced it with a lot of features and functionality that you can monitor. You can do a lot of diagnostic and many other features that we add on top of pgadmin. So you can definitely use some of the open source if you want, but what we are offering here with the Enterprise Manager is much more enriched, and a lot of enterprise features that you can use. So yes, you can download from, if you're a customer from EDB, you can download it. Otherwise, if you are a community, you want to use a open source community, you know, feel free to look at PG admin, right? So you can have a look at those. And then yeah, so these are the offering we have. Now, given the time, and now we should announce the winner. Thank you for all the questions, very much appreciated. I look at the panel, and we have a winner. Wojtek Masurik is the winner. So our team will contact you, Wojtek, and we'll send you the voucher. We'll get your information and contact you. So congratulations, winning the 25 euros gift card. And again, thank you everybody attending the session. It's been very active, lots of questions, lots of good questions, and very much appreciate our speaker, Piotr, a great demo, great presentation, and also the team answering questions at the background from Rob and Ed. Very much appreciate your effort and contribution there. And the team as well, Alice, thank you for hosting and sorting out the logistics for this webinar, and Sophie as well, helping out at the background. So thank you, team. Thank you, everybody. So we have one last question with the poll. Please fill in. And some of the questions that we might not have the time to answer them, but we will do the follow-up. We will answer them. We will send it back to you by email and then follow up on that. So with that, thank you, everybody. Very much appreciated your participations. And I wish you, or we wish you all the best and have a great day. Thank you, and hope to see you next time.
Thank you very much. Thank you for your time.